Welcome back to Tech Talks. So today we are going to look at parallel and parallel lines. Parallel and perpendicular lines. Parallel and perpendicular lines. So we are going to start with parallel lines. We're going to start with parallel lines. What do we know about parallel lines? Parallel lines have got the same gradient, and parallel lines, they are lines which don't meet. The angle between them is 0. Can say, consider two lines, L1, L2, L2 at an angle of alpha, theta on the positive x-axis, as below. So if you have these stuffs here, and we are calling this is line L1, line at an angle alpha, and this is L2 at an angle theta. This is x-axis. So you can see that line L1 and L2, they are not meeting, and L1 being gained at an angle theta, which means that these are corresponding angles and they are on the same, since L1 and L2 are corresponding angles. It implies that L1 has a gradient of M1, which is equal to tan alpha, and L2 has a gradient M2, which is equal to tan theta. Since they are corresponding on one angle, this implies that M1 equals M2, which means that tan alpha equals tan theta. So this means that parallel lines have the same gradient. Parallel lines have the same gradient. They have the same gradient, and the angle between them is always 0. So as we are going to be looking, how do we calculate numbers about parallel lines? How do we get a equation of the line on parallel lines? You can start with example 1. You can say, state the gradient on each of the following lines. Part A, 2y minus 3x plus 5 equals 0. Part B, 3y minus 5x minus 6 equals 0. Part C, y equals half x plus 8. Part D, 5y minus 2x plus 3 equals 0. So when you look at the solution for those numbers, so we need to first get a solution solutions. I've said state the gradient on each of the following lines. The first line is 2y minus x plus 5 equals 0. So what do? You first rearrange this one in terms of y equals mx plus c by making y the subject of the formula. We are given part A, 2y minus 3x plus 5 equals 0. So can we make y the subject? We are having 2y equals 3x. When they go there, minus 5. Divide out by 2. Y equals 3 over 2x minus 5 over 2. Then you say comparing with y equals mx plus c. So what does it imply? It means that the gradient m equals this one here. Gradient m equals 3 over 2. You have finished stating the gradient on that line. We have got part B. Part B saying 3y minus 5x minus 6 equals 0. The same story, make y to be the subject of the formula. So we are having 3y equals 5x plus 6. Divide out by 3. We are having y equals 5 out of 3x plus 2. Then we say comparing with y equals mx plus c. If we try to compare with y equals mx plus c, so what is the gradient? Our gradient m equals 5 out of 3. So that one becomes the gradient. So we are also moving to part C. Part C is saying y equals half x plus 8. Still we are comparing, can say comparing with y equals mx plus c. What does it imply? Our gradient m equals half, this one here. So, and we'll go to the next part, that is part D, as we're going to see the applicability of this. Part D goes that 5y minus 2x plus 3 equals 0. Still making y the subject of the formula, we are taking there. We are remaining with 5y, which is equal to 2x minus 3. What is y alone? Is 2 out of 5x minus 3 out of 5. We also say comparing with y equals mx plus c. What does it imply? It implies that the gradient m equals 2 out of 5. That's what we have already tried to get onto that one. Then we are going now to move on with another example where we are required to find the equation of the line. Find the equation of the line. Find the equation of the line passing through the given point. Passing through the given point and parallel to the line given. And parallel to the lines given in the following cases. We are starting with part A. I've got 2y minus 6x plus 7 at 3 negative 2. Part B, 5y minus 3x minus 2 equals 0 at 5, 4. Part C, can say 3y minus x plus 5 equals 0 at -2, 3. Let's try to look at solutions for these cases. What do we do when you are given? I've said find the equation of the line passing through the given point and parallel to the the lines given in the following cases. So the first case, we have got a line. Part A is saying 2y minus 6x plus 7 equals 0 at 3, -2. Can say this is the point and this is the line which is being given to you. So when you are given a line of this nature, the first step you are supposed to do is you are supposed to express it in terms of y equals mx plus c, and from there you get here the gradient which you'll use with this one to obtain the equation of the line. You can say 2y minus 6x plus 7 equals 0. Can take that one there. We are getting 2y equals 6x minus 7 when take those on that side. So what is y alone? Is 3x minus 7 out of 2. Then you say comparing with y equals mx plus c. So what is the gradient? So our gradient m equals 3. So this one is the gradient. And we are now having the point. We are having the point as 3, -1. You can say, if I have my point, I can call it A, 3, -2. I can call another point B, x and y. So how do we get here? How do we get the gradient of AP? You can say y minus 2 all over x minus 3 equals the gradient. What is the gradient? The gradient is the 3. So can we try to cross multiply? We are getting 3 into x minus 3 equals y plus 2. Can we open? We are getting 3x minus 9 equals y plus 2. We rearrange. This is 3x minus y minus 11 equals 0. So this one becomes the equation of the line which is parallel, which is from this point and parallel to this line. So the same way we are going to go to part B. Solution to part B, which goes that 5y minus 3x minus 2 equals 0 at 0.54. Now, can we make y the subject of the formula? We are having the 5y, which is equal to, we take this one the other side, which is 3x plus 2 divided by 5. So y alone is 3 out of 5x plus 2 out of 5. Then we say comparing with y equals mx plus c. So what is the gradient? We shall say the gradient m equals 3 out of 5. So we are going to use this very point. We're going to use that point. Can even say that point P lie on that with that point. If this is point B given as 5, 4, can call another point P x, y. So how do you get the gradient here? It will be y minus 4 over x minus 5, which is equal to that gradient, which is 3 out of 5. Can we cross multiply? We are getting 3 into x minus 5, which is 5 into y minus 4. So what are we getting? We are getting 3x minus 15 minus 5 into y minus 4 equals 0. So we are getting 3x minus 15 minus 5y plus 20 equals 0. So we are getting 3x minus 5y plus 5 equals 0. So you have finished getting the equation of the line which is parallel to this line at the same time passing through that point of 5, 4. So we are still moving on. We are now moving to part C, and part C goes that we are getting the question of the line which is parallel to 3y minus x plus 5 equals 0. What we do, we are going to make y the subject of the formula. So we are remaining with 3y. This one, when it goes, becomes x minus 5 divided by 3. We are getting y as a third x minus 5 out of 3. Still comparing with y equals mx plus c. So what is the gradient? So our gradient m equals a third. So we can choose that this point of ours is point A, and point A is given as negative 2, 3, and this is point P, which is xy. So how do we get the gradient of the line AP? We said gradient is through change in y coordinate over change in x coordinate, which becomes y minus 3 over x plus 2 minus minus, which is equal to a third. So can we try to cross? What are we getting? We are getting x plus 2 equals 3 into y minus 3. So can we bring this one here? We are having x plus 2 minus 3 into y minus 3 equals 0. Can we try to open up the brackets and collect like terms? So we are getting